Today we'll be talking about AI models that actually learn, where the industry is now, where it's going, and what you can do today to start preparing for that. So the best place to start is how these models are actually built. So when you think of something GPT 5.6, which is OpenAI's most recent model, the GPT-5 in that name is the base model. And the way you build a base model is you feed a ton of data and a ton of compute into a system that outputs what are called weights. These weights are just that model's understanding of the world mathematically represented. And if that sounds complicated, it's because it is, but the easy to understand concept is this is just a way for the model, when you feed it something, to understand or match it to something it's already learned so that it can provide an answer to you. So these weights are just its understanding of the world. The next stage, where you get the 0.6 in GPT 5.6, is the fine-tuning and reinforcement learning, or RL as it's known. Here, the model labs, AI or Anthropic, will build out a series of pass-fail tests and then have the model perform, readjust until they've optimized for getting the most right answers. The simple takeaway for how models are built is, one, you spend a lot of money and a lot of resources training an initial base model, and then you build out these pass-fail tests in order to train it and make it better at accomplishing specific things. And that's where you get the GPT 5.6. So the issue with all of this is that it takes a lot of money and resources to create these models. That's why there's such a long gap between something like 5.5 and 5.6 coming out. And that's not even the base model. The gap between GPT-4 and GPT-5 is much longer. So these models are starting to kind of wall. And there's a couple different walls they're hitting. First is the data wall. They have captured a lot of data in order to build these models out. And there's a lot of the data that's left is kind of into these private repositories. Company data is not out there on the internet for them to train models on. Or it's just in bad formats. So a lot of like Druction data, DOT data is just not easy to get. It's in bad formats. It's maybe sitting in physical form. It's not even in digital form. So that makes it very difficult to train this kind of into those models. Another and bigger wall that they are hitting is with the training method. These models that have been built are very good at online pass-fail tasks. So like code, does it build properly? Are there any errors in it? That's very easy to see. But operating a business or navigating a complex real-world situation, real life is messy, and it makes it very difficult to train these models, which can be trained using these pass-fail methods, on these more complex, more messy situations. It's another reason that things like driving has taken so long to build out compared to some of these other models, just because there's a lot more messiness or ambiguity surrounding what is correct and what is not correct in the real world. And lastly, even when you can find ways to, retrain or RL on all of this, messy real world information, retraining takes a lot of computation and a lot of time, making it impractical to constantly be doing that. This retraining or, learning process is something that us humans do very, very well. We can go into an ambiguous situation, we can learn about that situation and kind of how we approach that. So the next time we do it better. That process of receiving external input and changing, our understanding of the world is called sample efficiently. And humans do that very, very, very quickly. For models, because it takes so long to retrain and fine tune, their sample efficiency is not very high, which makes it very difficult for them to accomplish real world tasks. That's why the name of the game so far has just been, let's train them on as much as we possibly can. So if a situation is thrown their way, they have an idea of how to deal with it. While humans, we don't have that general breadth of knowledge, but when we're put into a new situation, we're able to figure it out. So the future for this technology really is this idea of models being able to learn from what's going on and adjust their weights accordingly. And that's where a lot of labs are spending their time trying to implement that into the model, or figure out how to efficiently implement that in the model to get that sample efficiency down. Some of the temporary solutions that you've probably seen a lot of are this idea of harnesses or memory systems. So agents can kind of save their memories on how they should be acting. This is very much a band-aid to the bigger problem, because it's not really the model learning. It's just creating a couple of rules for itself that it needs to follow. So a couple leading, technologies that you should keep an eye on are OPSD, which is on-policy self-distillation. If that's a mouthful, all it means is that a model after the fact, so after you have a conversation with it and maybe it did something wrong and you corrected it and you explained why that was the right way to do it, the model is able to adjust just the weights that pertain to that task. So in their entire big memory matrix that takes a lot of time and energy to build out, they're able to just fine-tune the weights associated with the task at hand. Another idea gaining traction is this concept of dreaming. So in neuroscience, one of the reasons scientists think that humans dream is to kind of run through in their mind, to prepare themselves that when they do encounter that situation again, they have a rough blueprint on how to respond to it. So that idea is kind of being extended to models, where a model can spin up a whole bunch of simulations based on a conversation or experience it just had, with all different slight variations, and then run through those simulations to determine what is the optimized output and how do I adjust my weights accordingly to account for that. This limits the overall downtime and lets the model handle kind of the reinforcement learning. What's really exciting here is that while this is all going on and while these larger labs are kind of hitting a bit of a slowdown, all of the open weight models are starting to catch up. And the reason that's exciting is that you have something like Kimi admittedly would take a lot of hardware to run locally. But in theory, you could have an organization that loads an open weight model or runs an open weight model and is able to leverage one of these reinforcement learning techniques to run and, more importantly, teach a model how to operate in the capacity of their business. So this is really, I think, the ultimate end goal, is that you have a model that you own, looking at the data that you own and able to learn on the job and continually get better at it. So what are we advising customers to do right now? And what are we at Bidlo doing to prepare for this? Well, first and foremost, a model is going to need essentially a classroom in which it can learn your business operations, it can learn what to do right and wrong, and it can work alongside you on a task that takes maybe days or weeks, and then distill that information and then go do that autonomously from there on out. These are like the real digital ways of the future. So as you see changes made to your Bidlo platform over the coming months, please keep in mind that this is what we are building towards. The platform as it stands right now is perfectly designed to help you with procurement, bidding, putting together solicitations, vendor management, schedule management, along with all the AI tools that we've built out to help automate those tasks. But the end goal here isn't for you to have to step through each of these tasks. It's to delegate that to an agent that is continually learning and optimizing itself to improve your bottom line.